numbers. Okay, then you have integers, okay, which is another circle. And then you have rational numbers. Okay, and that would be the big box that has all of them. Okay. Let me move that down. I'm going to still put it up there. I'm just moving it down where I got the room to actually do it. This. Delete it. Then once again you have rational numbers. And rational numbers are all numbers, including integers and whole numbers. Okay. Some people refer to it as real numbers. The set of real numbers include whole numbers, integers, decimals, fractions, both positive and negative. And so what we're talking about today is rational numbers. Okay, rational numbers are numbers that can be expressed as a quotient division problem of two integers. Okay, what we think of a division problem is just fraction. Okay, for example, this would be a rational number, 2.3. Okay, the reason that's a rational number is because I can express that as a quotient, okay, of two integers. And what you get is, first of all, 2 3/10. Okay, well, that's not two integers. That's three integers, 2, 3, and 10. But I can express 2 3/10 as 23/10. Okay? And that's the reason why it's a rational number. Now, they would take it a step further and say this is what a quotient is. Now, obviously, 23/10 and 23 divided by 10 are both quotient problems, division problems. Okay? The way we're going to look at expressing them today is the fractional way. Okay? So if a number can be expressed as a fraction, then it's a rational number. Most of the numbers that you know are rational numbers. Okay, most of the ones that you've been exposed to are rational numbers. Okay, for example, 0.3 with the bar over it. 0.3 with the bar over it is one I have memorized. There's a process to make it into a fraction. Is 1/3. Okay, and obviously if we were dividing it out, but we're talking about fractions today. So even repeating decimal numbers, we have terminating decimal numbers, we have repeating decimal numbers, things that we've talked about since 6th grade at least. Okay, repeating decimals are those with the bar over it, like I just wrote, 0.3 with the bar over the 3. That would be a repeating decimal number. Okay. A terminating decimal numbers, like I did with the 2.3, but it'll do another one, 0.7. What is 0.7 as a fraction? Really? So we just take whatever number's there and we put 1 over it. And that's how you make a decimal or fraction. 7 whole. So that's $7. Okay, so we're going to do our little transaction again. I'm bringing 70 cents tomorrow. You're bringing $7, and we're going to exchange it. No, what place value is this 7 in? Tenths. So, as we've discussed in many years before, it's the number over the place value, not just throwing random numbers out there that we place over the number. So if it was that, then maybe we need to discuss this a little bit more. 0.07. 7 over 100. Okay, if it was 0.007, then it's just 7 over 1,000. Now, if you could reduce the fraction, you would need to do that. For example, if I had 0.25 as a fraction, I look at the last digit. The last digit is in the hundredths place value. So that would be 25 over 100. 25 over 100 can be reduced by dividing the top and bottom by 25, which would give me 1 over 4. And that would be putting the decimal as a fraction. Now, if they give you 4.8, they give you 4.8 and they want you to express that as a fraction. Okay? There's two different ways to do it. You can express it as a mixed number, or you can express it as an improper fraction. Let me see which way they're going to want you to do it. I think they're going to want you to do it with, let's see. Yeah, they're going to want you to do it as a mixed number. Eventually, when you get into algebra, it's going to be okay to list numbers like that as an improper fraction, so you can manipulate it better. But same process is here. We look at this last place value. That last digit is in the tens place value, so that would be 4 and 8 over 10, because the only thing that goes over the 10 is the numbers behind the decimal. Okay, I would need to reduce that. That reduces to 4 and 4 over 5, or 4/5. Okay, the reason we did that, once again, because that's the tenths place value. Okay, now, it doesn't matter if the numbers they've given us are negative or positive. It's still the same process. If they give me, now let me get one out of the book. Let's see here. They give me negative 0.85, and they want me to make it a fraction or express it as a rational, or write the decimal as fraction. Okay? Well, what place value is the 5 in? Hundredths. So this is the hundredths place value. So that means I put 85 over 100. There's 85 over 100 reduce. Okay, what can I reduce it by? Okay, reduce it by 5, and that's 17 over 20. Now, it was started out a negative, so it ends up negative 17 over 20. And that would be negative 0.85 as a fraction. Okay? So if it went even further than that, let's say it was negative 5.895. And I'm changing the decimal to a fraction. Okay, well now, what place value is the 5 in? Thousandths. So that would be 5 in front of the fraction, then 895 over 1,000. Now we know that that can be reduced because the 895 ends in a 5 and the 1,000 ends in a 0. So we know you can divide 5 into it. Okay, once again, this was the thousandths place value. So if I divide this by 5, okay, 5 goes into 8 one time, remainder 3. 5 into 39 goes 7 times, remainder 4. 5 into 45 goes 9 times. 5 goes into 1,000 200 times. Now, it started out as a negative, so it ends up a negative. Negative 5 and 179 over 200. So to change a decimal to a fraction, we must first identify the place value of its last digit. Okay? And then we go from there. Now, what is a number that is not a rational number? Okay? A number that would not be a rational number would be the square root of 5. Okay? Here's why. If we look at it, I got to do that in there. Okay? There's the square root of 5. Okay? As you can tell, there's a whole lot of digits there. Okay? And they don't repeat. And in the sense of the digit or the number may repeat, but it doesn't repeat in the same order. In other words, 2.23606. Well, before the first 6 there was a 3. After the second 6, before the second 6 there's a 0. Then you go on down and find another 6, then there's a 9 in front of it. The same digits or the same block of digits or the same order of digits doesn't repeat. Okay? And that's just as many place values as this calculator has. Okay? If I was to find the square root of 5, it would go on forever. Okay? And that brings us to numbers that are not rational. Okay? Numbers that are not rational are called irrational. That's what most of you are most of the time. Irrational numbers. Okay? Irrational numbers. Okay? Irrational numbers are infinite or infinite numbers. What that means is it means that it will continue, the number will continue on forever and never repeat the same block of digits or repeat the same digit in order. Okay? So like the square root of 5, it's an irrational number. Now you're going, well, then all square roots. No, not all square roots. Because the square root of 4, okay, is there a square root of 4? What is the square root of 4? 2. Can 2 be expressed as a fraction? Yeah, 2 over 1. So the square root of 4 can be expressed as a rational number, 2 over 1. So it is a rational number. Okay? Now, there are a whole lot of irrational numbers because there is a whole lot of square roots that are not perfect squares. For example, another irrational number that you didn't realize was probably irrational is pi. 3.14 is just an estimate of what pi is. If you divide it out, okay, now let me divide that one. It's been a while since I've divided. Let's see, that's the equivalent, but that's going to end up repeating. Yeah, that's going to end up repeating. The fractional equivalent to 3.14 or pi is 22 over 7. But you can see that here, 22 over 7 repeats. 142857, 142857, 142857. So it keeps repeating that same block of digits. But realistically, the actual number for pi is an irrational number that continues forever. They've just rounded it off. Because you can imagine if we had to use pi and it was 22 digits long. So that means every time you multiply the perimeter, the radius of a circle times pi, you'd have to take, like
Mr. Max, real one, please.
3 times a 22-digit number. That would take forever. Okay, there wouldn't be calculators that could do it and all that. So what they've done is they've estimated pi as 3.14. But pi, the actual value of pi, is an irrational number. They've just approximated it. Same thing that we do with the square root of, say we have the square root of 6. That's not right. Clear. Okay, the square root of 6, well, the square root of 6 is going to be probably approximated to 2.45. Okay, and what they've done, they've just rounded it. They've rounded 2.449, and they've rounded it off to 45. Okay, so irrational numbers are numbers that are infinite. They never do stop. Okay, everything that we're going to be dealing with are going to be rational numbers. There won't be any irrational numbers that you're going to have to do today, but they do want you to understand what an irrational number is. Okay, now, let's see here. Let's look at how do I write negative 29 as a rational number. Okay, they want me to take negative 29 and write it as a rational number. Well, that means I need to write it as a fraction. Okay, there's 2 different ways I can write, there's actually 3 different ways I can write negative 29 as a rational number because it has the negative in front of it. I can write it as negative 29 over positive 1. I can write it as negative sign right in the middle, 29 over 1. And I can write it as 29 over negative 1. All 3 of those problems will be equivalent. Okay, but you do need to write them all 3 out. If that was positive 29, if that was just 29, then it's real simple. 29 over 1. And you're done. Okay, the positive ones are a little easier than the negative ones because the negative ones you can have it as three different ways and it still means the same thing. Now, your book is not going to use that way. Okay? Your book is not going to use it that way, so I'm not going to require you to write it that way. Okay, but that is another way that you can write it that's an efficient way to do it. So the only way you've got to write it is negative 29 over 1 or 29 over negative 1. Okay? And that's how we write it as a rational number. Well, what if we have I have 0.87 and I want to write it as a rational number? Okay, well, just like we've said, that means what? What's that mean, Copeland? If I'm supposed to write 0.87 as a rational number, what's it mean? What do we say is another word for rational number? Joshua? Fractions. So I want to write 0.87 as a rational number, then I just write it as a fraction. 87 over 100. Okay? And I'm done. That's it. So I've written 0.87. Now that one doesn't reduce, so I don't have to reduce it. Okay, if it, like I said, if it were reduced, then you reduce it. All right, now, the next thing we're going to talk about is changing a fraction to a terminating or repeating decimal. Okay, for example, I had negative 7 over 8. Okay, negative 7 over 8. Anybody remember what we do to change that to a decimal? If you don't remember, don't raise your hand and guess. Okay? If you do remember, or you think you really honestly remember, then raise your hand and let's see if you do. Laney, what do you think? We divide, yes, obviously, but what do we divide? What goes on the outside of the bracket and what goes on the inside of the bracket? Yes, very good. 8 is on the outside. 7 is on the inside. Okay, so you're always dividing the bottom number into the top number. Okay, doesn't matter what fraction you're dealing with, that's how you change it to a decimal. So now I just divide it out. 8 doesn't go into 7. 8 goes into 70. 8 times would be 64. Remainder 6. Bring down my 0. 8 into 60 goes 7 times, would be 56. Remainder 4. Bring down my 0. 8 into 40 goes 5 times. And that would be 40. Remainder 0. So 0.875. Now, has to be negative 0.875. Huh? What? What noise? What noise? My computer's breathing? Oh, it's the fan, yeah. It's the fan that's... No.
Oh, that's really good. That's hot. I'm cold. There's a fan in there?
It has to be, or it'd burn up. It gets real hot. My hand gets like right here. It's like a hot plate. That's where all the processing, the chip. But it's got a small fan that. All right, now, so you have negative 0.875. Okay, if it started off negative, then obviously you have to have the negative sign with your answer. Now, if we have, what if we have a mixed number? Doesn't change. 8 and 5 over 44. Okay. A lot of teachers will tell you that, hey, you got to change it to an improper fraction, then do it. You don't have to do that. That's just more work. More work and larger numbers. Don't do that. All we're going to do is take this 8 and eventually bring it down into my answer. What I'm going to do right now is I'm going to divide 44 into 5. I just always do that just as a habit. No, it's not always going to be 3 zeros. It could be 1. This one's going to end up probably 4 or 5 zeros after it. I just put that just because I know I need it. I need some zeros after it. So if I divide 44 into 50, it goes 1 time. That would be 44. Remainder 6, bring down my 0. 44 into 60, 1 time. 44, remainder 16, bring down a 0. 44 into 160. No, 3 times. 3 times would be 2, carry my 1, be 13, be 132, which gives me a remainder of 28. Bring down your 0. 44 into 280.
4.
That's more than 4. 6 times, yep, 6 times. And that's going to be 264.
This is an ongoing up.
Now, bring down a 0. It's going to be what? What is that, 26? No, 16. So 160, right?
Yeah,
so 160, and it goes 3 times. So that would be 132, be 28. So there it starts repeating this right here. Okay? So I bring it over here, and I bring down my 8, and then I have 1, 1, 3, 6. Put the bar over the 3, 6. Okay? So that's a repeating decimal number, but it still is a rational number because it started out as 8 and 5 over 44. Okay? Okay, any questions over that? All right. For your homework. It's obviously don't keep it, in other words, don't do it tonight and then do it Wednesday night and your parent, well, you got homework on Wednesday night. How's that possible? Well, because you wasted your time on Tuesday night. I would do it Tuesday. I would do it tonight. The homework is this: 5.1, 14 through 18, and then 20, hang on here, 28 through 44. Hang on. That'll work. That's it. 14 through 18, 28 through 44.